Today, we're going on a virtual tour. We're going to Wollongong. The University of Wollongong Sustainable Building Research Centre achieved full marks under the world's toughest sustainability standard for buildings, the Living Building Challenge, in 2019. This was designed by Joe Agius at Cox Architecture, and they won the 2015 Milo Dunphy Award for Sustainable Architecture. And the Research Centre has set a new benchmark, really, as arguably one of the most sustainable buildings in the country. In today's session, we're going to have the pleasure of hearing directly from the team behind the centre, Senior Professor Paul Cooper, the centre's founding director, and Dr. Craig McLaughlin, who's the centre's Research Facilities Manager. Craig's going to provide us with a guided virtual tour of the building. He'll be discussing the building certification systems, the biophilic references, the main operation of the building, the inbuilt tech, such things as thermal slabs and ground source heat pumps, transpired solar collectors, green IT systems, and other key aspects of the design that earn the building the full marks under the LBC. The session will then end with a Q&A between Dr. Craig McLaughlin and Mark Eckerman. Mark is the Product Innovation Manager at BlueScope Steel. BlueScope Steel has worked very closely with the University of Wollongong on this project, beyond the typical role of a material supplier. And through real-life product testing and research collaboration, both the University of Wollongong and BlueScope have achieved the outstanding building sustainability results we're seeing today in the centre. So without much further ado, I would like to introduce Professor Paul Cooper to the session, and he can give us a brief introduction and an overview.
Thank you, Michael, and good morning or good afternoon, depending where you are. I believe there's quite a few people online from various parts of the country and perhaps elsewhere. So thank you for joining us. And I would, just on behalf of our local group here, like to acknowledge the traditional custodians, the Alauri, the Wadi Wadi and Darawal peoples, on whose land we physically here at this SBRC meet today, and we pay our respects to the elders past, present and emerging. And so it's a great pleasure to give you perhaps a short overview of how this project started and where we've come to. So it was in 2010 when really the genesis of the idea of the Sustainable Buildings Research Centre came to be. And it was actually the start of our collaboration with BlueScope, because the primary idea behind the centre came from collaboration from David Varco of BlueScope Steel and Troy Coyle, who at the time was at the University of Wollongong, to develop a centre like this. And after a lot of hard work by all the stakeholders at the time, which included TAFE New South Wales and BlueScope and some other industry partners, we put forward a grant proposal and were successful in winning $25 million to build this wonderful building here and a facility for TAFE not far away. And Cox Architecture, led by Joe Agius, with Michael Bradburn and colleagues like Andy Marlowe, actually won a design competition to design this building here. And I was personally privileged to be working alongside the Cox team in really developing this building that we wanted to go way beyond the benchmarks of the time, which effectively was 6-star Green Star. And we knew that if we were going to be a sustainable buildings research centre with credibility and reach out into the wider world, we really needed to go way beyond that. And so we chose, after some good fortune of coming across the Living Building Challenge, to adopt the Living Building Challenge as our design framework. And Cox, the team there, welcomed that opportunity, really made life difficult in lots of ways because we were the first group in Australia to even attempt this. And the university gave us great support, Vice-Chancellor, signed off on it. And so we made the most of that excellent opportunity. And so fast forward to 2013, we'd done some great work with our industry partners, but particularly BlueScope. We'd incorporated all manner of products and ideas into the building that evolved out of our collaborations with BlueScope and using steel as a material. And some of those features you'll see when Craig takes you around the building. But we had our first prototype, for example, on the roof directly above me of a photovoltaic thermal system on the roof here, about 40 meters squared. Of that, we've incorporated cool roofs of different types on the building and done extensive research on that, developed new facade systems, and so on and so on. We've done a great many pieces of work with BlueScope, first and foremost in our industry partners, but with lots of others as well. And we took up residence here as a group. We just returned, as some of you might know, from winning the Solar Decathlon competition in China, the first Australian team to even attempt to enter a Solar Decathlon competition, and we won that competition in China. And so we came back to take up our place in this beautiful building, which, as Michael's mentioned, went on to win the Milo Dunphy Award. And it's a testament to the skill and basically the commitment that the Cox architecture team and the others in the building team more generally, our colleagues like Kundal, who looked after the ecologically sustainable design aspects and so on. And all of that has led to quite a success in terms of the trajectory of the development of the SBRC and recognition for the building itself, which in November last year was the first building in Australia to win Living Building Challenge accreditation. And for those of you who are familiar with that sustainability rating tool, you'll know that it's widely regarded as the toughest sustainability framework in the world. And we were accredited on all 7 aspects, all 7 petals of that framework, only the 3rd building outside of the United States to win that accreditation. So very proud of all that, and very proud of our team, who these days are working from home quite often, but a lot of us are still in the building doing exciting experimental work and so on. So I'd probably leave my little summary there. I believe we have later in the session some Q&A. So I might hand back to you, Michael, on that note.
Thank you very much, Professor Paul Cooper. Yes, Professor Paul Cooper is correct. If you do have any questions throughout the tour, then by all means, the chat box should be down below. So if you have any questions, pop them in there. What we'll do is I'll go through those questions at the end of the tour. So we now hand over to Dr. Craig McLaughlin, who is the Building Research Facilities Manager, and he will be taking us on a tour of the centre. So without further ado, over to you, Dr. Craig McLaughlin.
Hello, everybody. Hopefully you can hear me. Welcome to the Sustainable Buildings Research Centre. We're out the front of the SBRC, looking at the western entry, the main entry to the SBRC, and hopefully you can see one of the really striking features that I personally love about the design of the SBRC, the V columns that we've got at both ends of the building. Really magnificent bit of design and steelwork, and gives a real sense of scale to the building, as well as you can see there's also a solar shade. This is really where the beauty aspect, I feel, of the Living Building Challenge packs a punch. The solar shade, it serves dual purposes. It's reusing materials. Excess wood from the recycled timber floors that are in the building was put to great use here in this beautiful sunshade that provides an important function of shading the building on its western aspect for the low sun, particularly during summer. So without further ado, we'll start walking into the building and looking around and showing you some of the magnificent features that we have here. So I will try to walk nice and slow so it feels comfortable for those of you on the Zoom call. It's always difficult following along with somebody else when they're moving around, and I'll show you some of the key bits of the SBRC and the parts that really mean something to me. It's a real testament. I think there's lots and lots of features here that it's only after living in the building for quite some time that I've appreciated in the architectural design. So here we are at the front entrance. Welcome to the SBRC. Please come in with me. You'll be following along with myself, and you've just seen Robin Dawson, our administrator there. We'll be taking you through the building, and hopefully Robin's going to be keeping me to schedule. This is our exhibition space. This is where we welcome the public in and school groups to look at what's in the SBRC and hopefully to impart some knowledge about sustainability and what's possible with building design. Education and outreach is an important part of the Living Building Challenge, and also it's an important part of who we are at the University of Wollongong. We're really about imparting what we learn, using that knowledge to hopefully improve the world that we live in, and this exhibition space is a clear expression of that in these uncertain and strange times during the pandemic. Obviously, we haven't had groups through, but normally we would have a whole lot of different people touring through, from primary school groups through to industry groups. Coming over here, we have a scale model of the SBRC, and I'll bring you in a little bit closer to shot and hopefully give you a little bit of an orientation as to where we're going to go. Down in this part of the shot, you can see where I've started out in front of the building, looking at the sunshade. We're going to go through this wing of the SBRC, that's the office building. We're going to come over onto our rooftop testing area, and then finally we're going to finish coming through this other part of the building. So you might notice that the building has a H shape in plan form. It's very important for the solar design of the building, which is a really critical part of its performance. It gives us some really good solar access, and the design of the eaves and the shading mean that we get good winter sun and good summer shade. I'm going to bring you across over here to our materials table. This is another key part of the Living Building Challenge, the deep and thoughtful consideration of materials and the profound effect that they have not only on the building but also on the environment. Now, there's a lot of different groups who come in to see this materials table. As I said, we have school groups coming through to from primary school, senior students, but also industry. So this is really about educating any audience. So for the school groups, it's really just about planting that seed of the idea. You have to think about what's going into your building because it has an impact. The Living Building Challenge tells us that we need to be very careful of the materials, their manufacturing cycle, and their carbon intensity, not only of the material itself, but also of the transport chain. And all of those things you can talk about and see on this table, where we have materials such that are PVC-free plastics, recycled bricks, and so on. Now, the thing about this building and Living Building Challenge buildings is that they really put a focus on recycling materials. And that means that you end up with a building that's full of stories, because recycled materials have had another life, and another life means another story to tell. On this wall is an example of an amazing story that came out in a very surprising way to us, and it's one of my favourite stories in the building. If you can see just there in the shot, you can see a little bit of Art Deco green, and we were touring some of our colleagues from the main campus through the building, and one of the academics from social science, Dr. Chris Gibson, said, "That brick has been in 3 buildings, did you know that?" And we were amazed that we didn't. And what he was able to say is you can see that it's got green Art Deco paint. So it was probably a face brick in a Sydney townhouse somewhere. Then there's also some white paint on it as well, which is the hallmark of a brick that's then been the interior skin of a double brick house. And now we have it in our wall, evident in the building. So it's wonderful to think that that brick has actually been in 3 structures and still is going today and benefiting the people who made it. But also we're getting the use out of the carbon intensity that came out of that brick. So that's just one of many stories that's in the materials that make this building up. So now we're going to head through into the SBRC. So please come with me and Robin, and I'll show you some of the key features and the amazing things that we're lucky enough to have in our workplace, in our day-to-day environment and day-to-day life. So we're walking in past the training room where Professor Cooper and Mark Eckerman are. We'll come back to that later, but here's the main entry into the ground floor of the SBRC, into our corridor where we can go to the office or to some of our labs. As you can see, there's lots of wonderful recycled materials and timber evident that gives the building a fantastic feel. And over here is one of the most striking features of the building. It's our SBRC's green wall, tremendous biophilic element that really speaks greatly to me. The close interweaving of the natural world into the built environment and into the place that I come to work every day of the week it's really a tremendous thing. It's hard to put into words just the feeling that you get, the lovely background, welcoming and sense of place that comes from having the natural world brought into the built environment so much. I'm going to pick on another fantastic story from a recycled material in the building, and there's 2 of them in this table here. Firstly, if I come down and I show you the legs of the table, you can see there's some odd indentations in those pieces of wood. This is the second life for those pieces of wood. They've actually, in a previous life, been coil chocks in the BlueScope steelworks here in Wollongong. They were used to stack and store the 20-tonne coils of steel that would ultimately be turned into colour bond. As part of their life, they wear out and are unable to do that job, and then they've been recovered and turned into this beautiful table, which is just fantastic for such wonderful pieces of timber. Coming over to the surface of the table or coming to a closer detail here, you can see this little detail here. The builders tell me that that's called a bird's mouth, and that's from the roof of older style housing where the battens cross the rafters. There'd be that cutout where they'd connect the 2 together. And now that timber's been recovered and put into this table and given another life, and it's got a story to tell anybody who is lucky enough to sit down at the table. As well as that, we've also got this fantastic timber floor. So the floorboards themselves, they were recovered from some bridges in Queensland, and it's a pity that you can't see through those floorboards to underneath. The bearers underneath those floorboards are made of ironbark that was taken from a vehicle bridge from the University of Wollongong's own main campus. It was a single lane bridge that had served quite well, but unfortunately with the expansion of the campus, it wasn't going to do the job anymore. So it was dismantled and the material was sent over to us, and it's found another life as bearers in the underneath this floor. And the floor itself is just a fantastic piece of craftsmanship. It was put in by a carpenter called Morris Camacho and his workers, and they spent weeks gradually nailing it together from the side. So there's no nails evident in the top floorboards of the floor, and it's a really wonderful old school bit of craftsmanship that I think really adds to the beauty and the character of the building. So we'll head upstairs now while I talk a little bit about beauty. And I'm a mechanical and electrical engineer by training, and I think that beauty in buildings is really important. It might be a strange thing to say coming from such a hardcore engineer's mouth, but if something's beautiful, you care for it. And if you care for it, it lasts the distance, and the carbon intensity that's gone into that material and into that building lasts, and it pays back. So to me, making the places that we live and we work and gather beautiful makes sense from a carbon accountancy standpoint, as well as just making our lives better. Welcome to the first floor of the SBRC. This is the place that I'm lucky enough to work, and the first thing that you do is walk into the kitchen. You walk into the social hub of the building, and it welcomes you. And I think that's one of the fantastic features that I didn't appreciate until I've lived in the building that the guys from Cox put in, that you come into that social heart of the building, and the design welcomes you as well as the people do. So as you can see here, it's a tremendous space. We've got our open plan sections over here where we have our postgraduate students, and we have office cubicles, and I'm going to pan around and show you the other part of the building as well. And you can see that we have lots of wonderful natural light and recycled materials that give us a really tremendous character in the building. And that's weaving together a whole bunch of parts of the Living Building Challenge. A number of those petals, the materials petal with the recycled material, the biophilia that we've seen in the green wall, and the civilised environment, natural light. All of these things have come together and given us a really fantastic result here at SBRC. Now I'm going to come over here and I'm going to show you the view from one of our typical postgraduate research desks, and talk about some of the key features of the building and the Living Building Challenge. So some of the most significant technical challenges that you have to meet to become a certified living building is to be net zero energy and net zero water. And there's a simple principle that was espoused from the earliest designs and carried on through. Simple to say, but incredibly profound in its effect. For any resource that we're going to use, whether it be energy, whether it be water, or indeed materials, is that you should only use it when you need it. And when you do use it, it should be efficient, and then you should harvest what it is that you use. So that's had a whole lot of different effects. So firstly, we have to have really good passive design. So as you can see, we've got wonderful natural lighting here. So we don't need to use energy and artificial light when it's not necessary. We have excellent passive design in the building. I'm going to pan over here. You can see some more of that wonderful recycled brick, but that's part of a reverse facade where we've got our thermally massive structural elements on the inside of the building, and then outside we have the thermally insulating components of the facade. So that means that when you heat and cool the interior space and get the thermal mass of the building comfortable, you're not losing that or having to fill it up from the outside all the time. We're also a mixed mode ventilating building. So what that means is that whenever we can, we naturally ventilate, and only when that's not adequate do we heat or cool. So to naturally ventilate, we've got operable windows down here, down at person height, and then up here we've got higher level operable windows. So what that means is that if there's a breeze and we can open up the windows, we can catch the breeze from across the building. But if there's no breeze, it utilises the stack effect to have the buoyant heat draw cool air in from the lower windows while hot air goes out the higher windows. If I come down and focus here on a vent in the floor, they're strategically placed around, you can see that they're actually adjustable by the user. If you turn those vents, you can throttle back the airflow through them, and what that means is that you get some level of individual and operator control of the amount of heating or cooling that's coming to you at the station. So if you feel the heat or the cold differently to your colleague, you've got different amounts of clothing on, or you've been doing different level of activity, you can tune that to your own desire, which is a really critical thing in providing a thermally comfortable environment. We also, as mentioned before, we have a hydronic slab here. This concrete slab has a huge network of cooling water pipes underneath it. They're obviously not visible as they've been cast into the concrete. And they are another way that we're able to provide heating or cooling to the SBRC. And it's at this point I'd offer some advice to those of you who are looking at the SBRC. We are a research centre, so we've got lots and lots of features in our building because we want to study them all. I wouldn't necessarily photocopy this building and put it in as another sustainable building, because we've included things that aren't necessary as a double, because they're a double up purely because we want to research them. The best thing for you to do is to look at the building and look at the aspects that work best for your case and your situation and your place, and put those in. So that's just some advice from the researchers in the building. One other thing that shows the profound effect of that philosophy of resource use, only use when needed, do it efficiently when you do so, and harvest, is visible here on this desk. And you can see there's a keyboard and there's a monitor here, but there's no box on this desk for a computer like there is. You might be able to see back over here. And that's because this is a piece of IT that's called thin client, or has various other names. Effectively, you've got a screen and a keyboard, and that logs into a server somewhere else. And what that's done is it's taken the box off the desk, which in reality is probably a 200-watt heater. It's got about the same heat load as 2 people. And by moving all of those boxes out of this space, we've reduced the heating load that the building has to deal with, particularly in summer. And then that therefore has dropped the air conditioning load, that's dropped the size required of the air conditioning system, the pipes, the heat pumps, the whole lot. So by doing something as simple as looking at, well, do we really need that piece of IT equipment? Can it be done in a slightly different way? We've reduced the heat load, reduced the aircon plant size, reduced the energy demand of the building, which all has gone into reducing the size of the PV array that we've had to do to be net zero energy. And that's just an example of, well, simple to say, it's a very profound effect, that needful use, efficient use of harvesting. Okay, now I'm going to take you outside and we're going to see our rooftop and some of the other wonderful features in the building. I'm going to walk past our green roof and into this wonderful outdoor space. We have green roofs that I'll walk past. I'm going to go up these stairs and show you a view from the top of those where you can appreciate some of these features. It's a little bit windy here in Wollongong, so apologies if you can hear that in the microphone. Thankfully, the rain's held off. We've had quite a bit of that recently. So I'll turn around and I'll show you some of the features of the building. There's our green roof, which is another wonderful piece of biophilic design element in our building. Further over, you can see community gardens, and out the back of our building, we also have a reed bed that's part of our wastewater treatment system. Coming across the building, you can see we have the building's main PV array in 2 halves on either side of the building. Here, here. And in the centre, we have a more advanced piece of technology. This is a building integrated photovoltaic thermal array. This is some of the work that we've done with BlueScope. What we have there is not just a solar array. The PV panels are bonded onto steel sheets on top, and they are placed on the top of the standard profile roof sheeting, and that's created some channels through which air can be drawn. So on a cool winter's day like this, the sun When it's evident, we'll actually warm up the panels, warm up the steel, and warm up the air. And that air is drawn into the air conditioning system, and we're actually making use of that. Now, that's the system that we worked on in collaboration with BlueScope. That's a long-term demonstration of what's a reasonably unusual piece of technology here in Australia. We've also done work with BlueScope on more applicable to residential systems. I've just come over here to show you a testing rig that we have there. That's a rig that tests that technology, but at different orientations and different angles at a domestic scale. And with BlueScope, part of what we were doing is trying to understand the technical business case for that device, because one of the things that's not evident when you start is that when you place these systems in different environments, say here to Wollongong, if you're trying to create heating air on a winter's morning, you have a different situation. So this rig here might heat air by 10, 20 degrees, add that to Wollongong outdoor temperature that might be in the low teens. Suddenly you've got air that's really quite useful for heating. But if you put the same system in Canberra, say, where the air temperature in winter would be closer to zero, it's not quite enough. This system isn't long enough, so it needs to be a bit bigger. So to properly understand the environment and the business case and the climate zone that you're in is really critical to this kind of technology, and is something that was important in our work with BlueScope. That's been very fruitful today. Now, coming across something else I did want to show you here is the respect to the site and the local environment that the design has taken. You can see there Mount Kira. That's a really significant local landmark for us and for the cultural knowledge holders. Mount Kira is seen as a grandmother and a teacher and a place where you come to exchange knowledge. So that really resonates with us, being part of the university and being teachers and researchers as well. So one of the other things I'd like to point out here is the roofing materials. So on this part of our high bay roof, we have a standard roof sheet, and I'll pan over to look in the distance at another part of our roof. You can see in the shot, that's actually a different roofing material. That's Coolmax. It's a salt treated with a solar reflective paint, and we're looking at the impact of that on a real building. And by installing the two different materials here, we've given BlueScope Steel a real test bed where they can climb out and they can drill holes, install sensors, and really get an in-depth understanding of how the material performs in situ as opposed to laboratory setups. So coming down from the rooftop, it's a little bit windy out there. I'm going to come over and show you one of the other design features of the SBRC that I think took a lot of long and thoughtful consideration from the architects. This is one of the outdoor spaces, of which there are a number at SBRC, that we can have somewhere comfortable for the public to come to at any time of the year. And out here, this space is really nice in winter. It's protected from the elements and lots of nice sun. We'll often get students coming across from our accommodation block across the way. And but during high summer, it's not so good, but we've got other parts of our building that we are in shade but have this outdoor furniture where, again, we can find somewhere comfortable outside for the public to be, to sit, to rest, and to be in the space of this building at any time of the year, which is a crucial part also of the Living Building Challenge requirements that we're welcoming to the community and society at large. Just while I'm up here, something else I just wanted to point out. One of our lessons learned, I said that we had operable windows here as part of our natural ventilation strategy. Some of the lessons that we've learned here, and it might be a bit heretical, is that I wouldn't necessarily copy this design in the future to provide natural ventilation. I'd maybe propose a strategy more based on fresh air. We've found a couple of instances during these really unusual times. Firstly, during the bushfires, The outside air wasn't something that you wanted to bring inside because of all the smoke particles. We had to close the windows and weren't able to really use those windows as part of our conditioning strategy. There's also similar concerns about air supply during the pandemic, but more simply during spring, now where we are now, hay fever sufferers have real problems with pollen brought in just by outside air. Perhaps a better strategy might be to use more fresh air through air handling units that we're able to filter. So just a lesson that we've learned in this arrangement. So we're now going to head downstairs and I'm going to show you into one of our laboratories and talk to you a little bit about some of the work that we're doing there. Again, you can see some of the wonderful recycled brick as we come down. And we're coming through back down just to orient you. That's the green wall that we started at and the stairs that we went up to the office space. And now we're going to take you into our high bay laboratory and show you one of our largest research pieces of equipment, our building insights facility. So this imposing structure is the largest piece of research equipment that we're developing under the grant that we were given here to build the SBRC. We just turn around and show you the control station for this facility. This facility is all about looking at thermal comfort and the thermal performance of structures and then giving us information about the impact of those on energy use in the national grid. So one of the things that we're interested in here is thermal comfort, how that's perceived by people, and we're able to do some of that testing in that climate controlled chamber to look at how thermal comfort is felt and perceived. Another thing that we're able to do in that facility, and I'm going to turn and show you another aspect of that, is test air conditioning systems. Because thermal comfort is really the product of the air conditioning system and the facade of the building that you're placed in. And that's something else that this facility can also test, is facades at full size. So I'm going to pan around and show you the test cassette that we're able to install a facade in and test it. So Robin's standing there to give you a sense of the scale. Now that orange frame is our facade test cassette, roughly 3 by 4 meters, and that's the size of a real piece of facade that we can build into that test cassette and bring this device up to contact with, called a hot box, for those of you who have ever had anything to do with testing of R value at full scale. So that device is a meter that puts heat against the facade, and we're able to measure that in a calibrated way and calculate the R value of a full-size facade at full scale, which is something that's really important. And it's also the building blocks upon which we can do more advanced testing at full scale of thermophysical performance of facades, whether that's starting to look into their hydrothermal performance or into the impact of air movement on the R value of the facade. So moving down our high bay, I'll stop in at one of our other really significant bits of experimental facility. Here is our flex grid. So there's a really profound impact that air conditioning for thermal comfort has on the national grid, and energy cost, energy use, energy price is a really important topic in the current environment. What we have here is a facility where we can test up to about 30 kilowatts of power flow at real scale, what a small piece of a grid might look like. We can put on real load from our SBRC building onto this electrically real PV. We can bring in devices to test. You can see that that's a pole top transformer that you've probably driven past a lot. And we're testing their performance in a real grid environment to look at that whole story of energy use, from the thermal comfort through to the HVAC, through to its impact on the national grid. So one of the last things I wanted to show you as I come back through the SBRC, and we'll head over to Mark, is this is the water treatment station here at the SBRC. We're net zero water. As I said, we collect all our own rainwater. We process all our black water on site through a reed bed. And this is the facility that we use to filter our captured rainwater, 3 stages of filtration for use in everywhere that we're legally able to do. And it's a much more modest system than was originally designed. It's again an example of the original system was about 3 times the size, but all of the existing design assumptions were challenged, and the scale of the system came down to something that was far more sensible. And this system is simply supplied with rainwater that's stored in an underground tank just under these gardens here. So that's really about all the time I've got for you today to show you around the building. There's many, many more things that I could show you and talk for a long time, but we are limited in our time. So right now, as I come back to where we started at those wonderful V columns and the entry to the SBRC, I'm going to hand over to Mark Eckerman from BlueScope, who's the Product Innovation Manager, and I'll step in and join Mark. So I'll sign off from there and hand back over.
Thanks very much, Craig. The look at the building I never get tired of seeing, so great to see it again. My name's Mark Eckerman. I'm the Product Innovation Manager at BlueScope. I've been there about 25 years and my background is materials engineering. The product innovation role of BlueScope and the responsibilities that I hold are more about segregating the long-term and the breakthrough innovation work, which can too easily get consumed by the day-to-day firefighting. So we made a decision some time ago to ensure that we give focus on the things that might take 5 or 10 years to come to fruition, but that they need that investment and that focus. And like most businesses, as the day-to-day pressures come to bear, it's very easy to lose focus on your long-term. So my remit within BlueScope's product innovation is to really hedge off the team and make sure they stay focused on the longer term product innovations that will yield us successes down the track.
So as many of you would have heard with Paul's introduction, there's some really long and deep links here between SBRC and BlueScope, ranging from the original ideas that led into the grant, that's led into the ongoing partnership. So I'm wondering if Mark might want to touch on some of the close connections that are meaningful to him from the BlueScope perspective.
Absolutely, Craig. Look, I reckon that the beer coaster-like moment that conceived the SBRC is just a classic Australian story. I'm not sure if it was a beer coaster or an official piece of stationery, but that moment of conceiving this brilliant building just started a long series of interactions. We were a gold pillar sponsor, so obviously we had a huge role in what's the fabric of the building, various experiments and placements of our materials into the building. But then once the building became operational, we started with a collaboration agreement. That then got swallowed up by what was the first steel research hub, and we're now actually just in the break before we enter into a second steel research hub. So those formal programs of collaboration have seen us work together on a whole bunch of different experiments, building systems and prototypes. Off to the side there, and while this program is finished, there was also the Cooperative Research Centre for Low Carbon Living, and both BlueScope and the SBRC did a number of really important programs through that facility. At a more intimate level, you can walk around the building, you can name the staff that are here and we're at BlueScope, and you can name the staff that were at BlueScope and were previously at the SBRC. So for some of us at BlueScope, this is like a second home. But then if we just expand more broadly, and this is where my story comes into it, University of Wollongong more generally for decades has been the breeding ground for BlueScope cadets that go on to fulfill all sorts of engineering roles through BlueScope. So my own story started as a cadet at the University of Wollongong with a very tailor-made program that allowed me to work and study. And so BlueScope and the UOW more generally have been partners for many, many decades.
Thanks, Mark. Just looking at Paul Cooper here, when Paul set SBRC up, it's really had a focus on applied physical testing as something that's really in our DNA. So we believe in real life testing, and you've seen that with a lot of the things that we've put in the building that we've used as we've lived in it and researched in it. So that's important to us, but I'm wondering why that real life testing is important to BlueScope from Mark's perspective.
There's nothing that gives something a real life warts and all shakedown like putting it into service. And here you see experiments that are actively conditioning or being part of the building every day. It's easy to build things in the lab and they look perfect and you've got a whole bunch of scientists building it. But what happens when you ask a bunch of trades to do it on site, in the weather, with the tools they have available, with the tolerances that are reasonable to expect from a construction team? It's a really different scenario. You then take that same experiment and you say, what happens when it goes through 5 years of rain, heat, UV, hail, storms, and even down to some of the really eclectic things like, do our white cockatoos love to eat the stuff? You can't do that in the lab. So real world testing is just priceless. The other thing that durability testing links BlueScope and the SBRC through is if it lasts in the real world and it doesn't need to be maintained in terms of energy or time, and if it lasts the duration of the building, that's a great contribution to fundamental sustainability. So that really ties in nicely with BlueScope's own history of putting real world exposure testing at the forefront of our program, where we have a number of sites around the country that similarly we look at accelerated cabinets and accelerated test results, but the results that really matter is when you put it out in the harshest environment and see what nature can throw at it. So there's a really nice link in there.
Mark's just triggered off a whole lot of memories for myself on the roof of this building with the BlueScope guys looking at, we'll need vermin mesh and all sorts of stuff, and the disagreements with some of the tradies that we had that I'm sure many of the other people on this Zoom will have had. Again, going back to Paul, setting up this research centre, we're about applied research, but you've got to be collaborative. We think in doing that, we can't get anything done in the real world just by ourselves. So it's important that we can work with research partners, and BlueScope's been really important for us from our inception. So I'm hoping and looking for a shameless plug for our research centre that there's been some good benefits in Mark's eyes from the BlueScope perspective.
Absolutely. I guess the key benefit that I see is when we get into really complex building scale phenomenon, that's well beyond the facilities and the expertise that we have at BlueScope. And I suppose I'll tell you about a recent research program that's really taken a close look at the way we classically build a steel skinned wall system in Australia, and what really happens with the solar radiation, the heat and the moisture as it interacts with that wall system. That interaction is really important because any wall like that has got to strike the right balance between energy efficiency, managing the moisture. It's got to be buildable, it's got to be cost effective, and it's got to be durable as well. And what we've seen recently is a lot of building system standards and codes that are just being grabbed from overseas in a very climate specific area. So it might be a classic European cool climate. And what we see is a very dangerous temptation to grab things like that and say, let's bring it to Australia and let's pretend that it works all the way from Hobart to Darwin. Now, it might work all the way from the 200 kilometre band in that European country, but we all know that Hobart and Darwin are just completely different beasts. So the facilities like the Building Insights facility, the researchers that have the ability to use software to do the modelling, to look at all 8 climate zones, to look at a wall in north, south, east and west orientation. That gives us all the correct data to make the correct adjudications about what are the correct building codes and building systems that really work in Australia, and how might they need to be adapted when you take them to Darwin as opposed to when you take them to Hobart. So that's stuff that we can't get near at BlueScope, and that's where this collaboration has just been so beneficial.
Fantastic. Well, that's the questions that I had. So I'm wondering if our moderator can tell us if there's anything from the audience that we could go in. Thanks, Michael.
Absolutely. We have got a lot of questions that have come in on the chat, probably a lot, and I'm just going to apologise in advance if I can't get through them all, but we will try. So just again, for those who have joined us in the last half an hour or so, sitting in this room, we have Senior Professor Paul Cooper, the Centre's founding director, Dr. Craig McLaughlin, who's taken us on that tour. He's the Centre's Research Facilities Manager, Mark Eckerman, who's our Product Innovation Manager at BlueScope still, and on the right is Daniel Davis. He's the Senior Product Manager for Commercial and Civil Construction. So great to have you with us, gentlemen. Let's get cracking and let's ask some of the questions that have come through, if that's okay. We have, like I said, got quite a lot. Okay, let's start. We started obviously at those beautiful V columns that you were talking about there. Now, this is an interesting one. This is in relation to concrete, excuse me, concrete slab floor finishes in that entry area. What's in the concrete? Is it fly ash, obviously a byproduct of coal production, which is a great ESD, environmentally sustainable design concept. Is fly ash in that concrete slab?
I don't think so. I might have to take that on advisement. So I think coal wash.
So at the time, so the short answer, I believe, is yes. And bearing in mind that this construction started in 2011, something like that, the concrete that was used throughout the building was low carbon content concrete and at the highest level that we could get at the time. So
great stuff. Thank you. And in relation to the ceiling lining material, what's on that first floor raked ceiling?
There's acoustic tiles on that first floor that assist in keeping the noise down. You know, with the open plan, there was a bit of quite a lot of thought put into the design of the building, that you have some principles of natural ventilation, cross ventilation being in conflict with some acoustic insulation and privacy, particularly when you're trying to do things like academic work and study. So that is an acoustic treatment to try and keep the noise level down while allowing for the cross ventilation.
Talk us through how the air conditioning system worked, especially during COVID-19. You talked about the building being empty, it wasn't occupied. How did the air conditioning system, that chill beam system, function during the COVID lockdown?
So we've got a couple of things in place. So we're a mixed mode building. So wherever we can, we use fresh air from the outside. So we modulate the operable windows to the relevant point to try and bring our zone into comfort. And then from there, we've got two ways we can put heat or cool, if you will, into the space. So one is via air. We have a series of ground source heat pumps or an air source heat pump that cool or heat water. That's sent through to the air side air conditioning that is brings that air in from underneath in those vents that I showed. Or you can use the hydronic slab, and we can pump hot or cold water through the winter months. What we would do is use the hydronic slab overnight, and we would warm that up, and then during the day that would be augmented and topped up with either fresh air or some warm air from the air side air conditioning.
Talking of the windows, are they just standard aluminium powder coated windows? Is there anything special in relation to their design?
Well, they've certainly got really high performance glass, and probably a lesson that we've learned is we've got hundreds of operable windows with actuators that are all a maintenance problem. So if you're going to do that kind of design, allowing people to get to those actuators is important. And as I mentioned, it's really that's something that I would stop and think about before doing again, that possibly the better way to provide outside air that's of good quality may not be through operable windows. It might be through an air handling unit with a filter bank that you get some control over the air, be that pollen or bushfire smoke. And the energy used by an air handling unit fan could be a relatively small amount that could easily be recovered by a pretty modest kind of solar array in a net zero sense over a year.
In terms of, let's go up to the roof. Let's look at those plants. This is quite interesting. And we're now going to come on to more of the biophilic side of things. And I will say, just a quick plug for the Institute of Architects, don't forget that our environment guide, which sits on Acumen, has a fantastic environment note on biophilic design. And it actually includes a short case study section on the biophilic response of the projects that we've looked at today at the University of Wollongong. So do check that out. But let's get back to that biophilic stuff. What were the decisions in relation to the plant species? Some of them look like vegetation in terms of herb gardens and stuff like that. Talk us through what's up there.
Well, there's a few things that are going on the green roof space. So there was sections there with small plastic tubs. So that's an experimental site where we can look at various different plant species. We've had interest from some of our researchers in looking at, well, what's the right kind of species that's hardy, that's adapted to the local environment, doesn't need additional watering. They're the kinds of things that some of our biological researchers have been interested in. You spotted that we had a kitchen garden, so obviously that's got herbs, not native species, but herbs and things that go pretty well on a toasted sandwich, I have to say, and a number of other things, some nice salad greens, and then there's another part of the roof that's a garden for biophilic and beauty's sake, and that fits in with the overall sensibility of the garden design here, that we're using the natural species that we know exist here from an adjoining nature reserve. So we've looked at what species are here, and the landscape architects, a firm called Taylor Brammer, did a great job of looking at, well, what were the species that are endemic to this part of the world and this particular part of Wollongong, and what can we bring across into the SBRC, and many of those are a good bush tucker species as well, which is part of the Living Building Challenge and the responsible sourcing of your food and that sort of thing.
Being conscious of the compounds that can be released when you're talking about varnishes and things like that, what's the floor finish on that upper deck?
Now that I don't know specifically, but it's definitely a low VOC product, and I know that there was a lot of care taken in selecting it to comply with the Living Building Challenge materials pedal. So I might have to take that one on notice to get a specific product name, but definitely a lot of care was taken in. I'm pretty sure it was a water-based product that was used. I have to get back to you on exactly what it was.
Great stuff, thank you. Now, this is an interesting one, and it's going to really, I'm going to struggle with some of the pronunciation, I'm sure of it. This is a question which James Norrish has put in the chat, and this is in relation to more of the psychology and the physiology of the people that occupy the building. So this is in relation to seeing if you've taken any measurements on the melanopic lux, the effects of light acting on the IPRGC. Now, the IPRGC is the, from memory, it's the intrinsically photosensitive retinal ganglion cell, which is, it's a type of neuron which is in the retina. So basically saying, have you done any studies on human wellness since you've had occupants in the building over the last few years?
Short answer is yes, and I'll throw you to Professor Cooper for some longer answers.
Well, to my knowledge, we haven't done anything along those lines, James, so that you mentioned there. But we have done a number of post-occupancy evaluations, particularly using the University of Sydney's BOSSA methodology. And at the time that we had those tests done, and that's a combination of looking at actual indoor environmental variables, temperature, humidity, radiant temperature, and acoustics and all that sort of thing, but also occupant feedback. The response from the occupants was very favourable, right up in the top 2 or 3% of the database of buildings that they held at the time. Doesn't directly answer the question, but I did say, no, we haven't done the melanopic, lux.
Melanopic lux, yeah. Let's stay with lighting again. Another question from James, a follow-up one, and this is in relation to the artificial lighting that you've got in the Building Research Centre. Is it dimmable? And if so, do the LED drivers conform to that Wilkins Research safe frequency over modulation model?
Again, some of that I'm going to have to take on notice.
That's okay. Highly technical questions. I thought we'd get a couple, but I just thought I'd throw them in just to see how you'd go.
Well, maybe to flip around a little bit, the way the lighting works is that throughout the various areas of the building, we do daylight harvesting. So if there's enough natural light, then the lights don't come on. And then if the natural light isn't sufficient, it's augmented by lighting that's progressively dimmed up. And then each of the researchers' workstations has an LED lamp that's itself adjustable at a number of levels and has a proximity detector. So the idea being with the lighting that there's enough lighting applied just for general access and egress and moving around using that daylight harvesting, and then there's something that each of the individuals can tailor to their own needs and eyesight at the time of day.
Did the livable building certification, does that recognise or reward the use of thermal mass inside the building? This is a question that's come in from a gentleman called Mark, and he says, look, he doesn't think that Green Star gives any credit for this, but it would improve the energy savings in buildings. What's your response?
Well, I'll take that one. And I saw that come up on the chat just very briefly. Yeah, it's an interesting question. And the short answer is the Living Building Challenge doesn't speak of a thermal mass specifically in terms of energy consumption and thermal comfort. So really, Living Building Challenge has got very high level metrics, so to speak. So you have to comply with the relevant thermal comfort criteria and so on. And you need to do that in a net zero energy building. So that constraint, they're the constraints on the design of the HVAC system and the architectural passive design and so on. But the one thing that the Living Building Challenge does do, which I think is incredibly important, it requires the developer, in this case the university, to pay a carbon offset for the total embodied carbon in the building. And that's not, you cannot, at least under the version of the Living Building Challenge that we built this building on, you cannot simply just put a few more extra solar panels on the roof to eventually wipe out that embodied carbon of the building. Because in a sense, that doesn't really drive the designer or the architect or the SD people to dematerialize a bit the building and reduce the overall embodied impact. It's the financial penalty in effect that makes that happen. So we went out and bought carbon offsets from accredited Gold Star level to offset that total carbon embodied.
Let's talk quickly then, because I'm just conscious of time and there are still questions coming in. So bear with us. We might stretch this out just by 5 or 10 if that's okay with you, but this is some fascinating questions coming through. Let's talk about BlueScope's great product range in there. You talked about BlueScope steel roofing. You talked about integrated PV panels. Question again from Joe on the chat is the steel roofing and the panels, are they just supported by timber or steel roof framing or and roofing battens, or have you installed a ply sheet or substrate directly under the roofing sheeting?
So the roof sheet itself, the what carries, say, the building integrated photovoltaic thermal, that's just a standard steel cold rolled beam that holds that up. And then we've created channels on the top of that corrugated roof shaping just by a standard steel sheet that's painted, and then the PV panels bonded onto the top of that. So I think I've answered about a half of the question that you've posed there, but I'll take that as a pass mark.
No, it's absolutely fine. Thank you. Now, 2 more questions. Let's go with one. And this relates again to wellness. What about the colours inside? I mean, we've talked previously in lean-ins in relation to colour, how it stimulates mood, how it can affect reaction, how it can make you feel. Talk us through the colour choices that you've made within the building centre.
Well, that is probably best put to the interior designers from Cox, because we were guided by them very much as to how the interior was going to look once the basic palette had been chosen. So once we decided to use reused brick, and I have to say that I was one person who originally sitting around the table said, no, I don't want visible brick. I come from London. I'd seen enough brick in my life, but I was convinced, no, let's see this beautiful reused material. And I was proved wrong. It's beautiful. So once the palette of the raw materials, recycled wood and the brick and so on had been chosen, then the colour scheme was chosen around that.
Great stuff. Final question. This comes down to cost. Now, you may or may not have this information to hand, but have you done any work in relation to working out the cost per square metre of the build? Has there been any cost comparisons, especially done between the building that you occupy now and previous conventional buildings? You know, is it a cheaper building to run than a conventional standard university block?
Well, it's certainly a cheaper building to run. In fact, it costs nothing. And in fact, we effectively generate, I can't remember exact revenue from the PV system, but in terms of running cost, from an energy point of view at least, and water probably, there's no cost there. But I suspect the person answering the question is also interested in capital costs. And look, we have, one of the things that's been a little difficult, I wouldn't say it was a cheaper building to build than a conventional building. We would never claim that. And I don't think Living Building Challenge buildings have been demonstrated to be cheaper. There is something of a cost premium on there just because of the very rigorous choice of materials. But it's not excessive, but I don't have the figures in front of me. One of the difficulties, I might say, just as a caveat, one of the difficulties is that, as Craig was saying, there's so many embedded research technologies in here, not least the fact that we have got a thermally activated slab, ground source heat pumps, all these sorts of things embedded within the building. It's very hard to unpick all of that from the basic cost program.
No worries. I think what we'll do is we'll probably leave it there for questions. I'm conscious of the time. People have got to get back to meetings and that sort of stuff, but it has been absolutely fascinating. And thank you so much to all of you for taking the time to go through and give us such a great tour. So thank you so much, Craig McLaughlin, and for doing that tour. I think that was just absolutely fantastic. So thanks very much for that, Craig. And of course, for you, Senior Professor Paul Cooper, the founding director of the Sustainable Buildings Research Centre, we really appreciate that. And a huge thanks, of course, to the host and sponsor of today's Lean-In session, Mark Eckerman, of course, from BlueScope Steel, and Daniel Davis. Great to have you with us. And I'm sure that there'll be lots of questions and a lot of follow-up, of course. So do direct your questions to BlueScope Steel if you do have any further questions about what you've seen today on the tour, of course. I am just going to give one final plug in the chat, and that is just in relation to the biophilic design, which actually features the Sustainable Building Research Centre. It's on our Acumen site as well. I really, there's the link. I've just popped it into the chat for you. Do have a good look at that. There's probably not a better example of biophilic design than what we've seen today. So do have a good look at that on our Acumen notes. So please go and enjoy that. That is it for today. Thank you very much for joining us, and thank you for joining us in Wollongong, and look forward to seeing you all again until our future Lean In series next week. Do take care, stay safe. I'll look forward to seeing you again very soon. Thanks very much.